The guess technique. Now, when I say the word guess, most people think of, well, the first thing that comes to their head. But you'll notice that it's capitalized, and so the guess technique is not exactly what you think. By the end of this lecture, I hope to develop a method for organizing information and solving word problems. So basically, this is a system in which you can solve word problems. Now, when I first encounter a word problem, the first task that I have is to identify what's important and then how it fits into some sort of formula. And this is where the guess, capital G, capital U, capital E, capital SS technique. It is a systematic way of organizing information in order to solve a word problem. Well, every letter means something. For example, G stands for given. And in essence, this is where I record information that's supplied by a question or what I know that will help me. U stands for the unknown. What is the question actually asking me? E stands for equation. What math formula is really going to help me here? The first S stands for substitute. Let's replace all the letters in the formula with the numbers in my givens. And S simply means solve. Hey, go do the math. So in this example, a runner is at the starting line of a race. After the gun goes off, they can get to 4.5 meters per second in 2.5 seconds. What is the runner's rate of acceleration? So if I were to use the guess technique, I basically identify what the givens are, the unknown, and the equation, and then later I'm going to substitute and solve or simplify. I see that a runner is at the starting line of a race. That's going to become important in a little bit, but let's keep going, and I see that the gun goes off and they get to 4.5 meters per second, right? There's a dead giveaway of what the number 4.5 is, and that is a velocity. But my question is that the beginning velocity or the ending velocity? Well, if you look, does the runner start at a starting line? So what is this runner's initial velocity? 0. And that means that this is a final velocity. And that the velocity initial is 0 meters per second. And then finally, we have a time here because that's in seconds. And so time equals 2.5 seconds. And next, it becomes what is the rate of acceleration. So we're looking for acceleration. So I'm going to write A here. And then I'm also going to include the units for acceleration, meters per second squared. At this point, I need an equation that deals with acceleration, time, velocity initial, and velocity final. And if you pay attention to your blue card, I think it says acceleration equals velocity final minus velocity initial divided by time. At this point, I'm just simply going to replace numbers for letters. I don't know what acceleration is. It's my unknown, so I'm going to write it again. Equals. Do I know what velocity final is? Yeah, it's 4.5. I'm going to subtract the value 0 from it. I'm going to divide by the time, which is 2.5. Now at this point, I'm going to simplify the numerator of my fraction, and I get 4.5 divided by 2.5. I've simplified from here to here. At this point, I'm going to get out my calculator and dump this into it. And you get a value of 1.8. I'm almost done. I need to include the units, meters per second. And if I check significant figures, I see that this number has 2 sig figs, and that number has 2 sig figs. But wait a minute, Faye, what about that number? Does that number have 2 sig figs? I'm sorry, 1 sig fig? Nope, it has infinite sig figs. So the number that has the fewest is 2 sig figs, and so according to significant figures, my number is 1.8 meters per second, squared.